Cryptography and steganography via memes, exploring anti-forensic tactics and investigative countermeasures. Michael Trammell, cybersecurity, AI, and cloud practitioner. Hello, my name is Michael Trammell. I'm excited to be here today. A little bit about myself. I hold a bachelor's degree in business administration. I have 10 years experience in the legal field. I will be completing my master's degree in cybersecurity in December, which that's actually next week. I also completed a fellowship this year that I earned through Kennesaw State University. I'm a member of OSEG. I have a couple governance, risk, and compliance certifications, one in integrated risk management and response planning. I also hold a certification in the AWS Cloud Practitioner, also an AWS AI Practitioner. The internet has become a fertile ground for innovation, both in legitimate and illegitimate activities. Among the most surprising and unsuspecting tool that is being exploited by cyber criminals are memes. These are visual content that's often humorous and they're usually culturally significant, normally on Instagram, Twitter, even Facebook, or you might even get someone send you one through a text message. However, memes hold a darker potential. They have the ability to transmit hidden messages in plain sight. With the capability to reach millions of social media users instantly, they serve as an ideal medium for cyber criminals to communicate covertly. Beyond their humor and cultural impact, these seamlessly harmless images can function as sophisticated vehicles for encoded messages, challenging the, challenging the traditional boundaries of cybersecurity and digital forensics, actually making the job of investigators hard. Steganography and cryptography are tools that are used to conceal information, and we will also talk about how hidden messages can pose challenges to forensic investigations. The motivation behind my research was to focus on the increasing use of steganography and cryptography in illegal activities, basically on the dark web and again in plain sight. It also aims to shed a light on how memes, as ubiquitous of a digital medium it is, how cyber criminals are using these to conceal messages. Some of the things that can be placed in these are personally identifiable information such as credit card numbers, social security numbers, and things like that. It's just as something as simple as I post this message on a forum, and the intended receiver, they have the password, and they go ahead and they can just do what they want to do, and it's not tracing back to me. This is downloaded by millions, but the one person who's looking for that image sees what's going on. These hidden communication tactics use various methods to bypass detection, which they often go undetected, which is overwhelming for forensic investigators. This is a significant legal challenge for law enforcement globally. Memes are very effective for such purposes as they are widely shared and they're rarely scrutinized by investigators. Most people don't pay them any mind. They just look at them and laugh. This research examines how malicious actors combine cryptographic techniques and steganography to conceal their activities with images and memes. This is a very potent anti-forensic strategy, and it renders detection basically useless by traditional means. We will also evaluate modern investigative tools such as counters, steganography software to understand the effectiveness in addressing these new challenges. By analyzing the limitations of current forensic tools, the research aims to propose new methods for unearthing hidden data and countering the use of sophisticated tactics by these cyber criminals. Understanding steganography and cryptography. We're going to call it STEG for short. STEG is the art of hiding information. This has a rich history that dates back years ago, and it continues to evolve in complexity alongside the advancements in technology. It originated in ancient times. This practice serves as it was a means to secure communication, utilizing techniques such as invisible ink and wax-covered tablets by the Greeks, dating all the way back to World War II. Microdots hidden in images marked a significant advancement, demonstrating how STEG adapted to new technologies. With the advent of the digital era, STEG found a new medium in multimedia files. Early techniques such as least significant bit or LSB replacement allowed hidden information to be embedded into pixels with minimal perceptible changes. Further innovations leverage mathematical transformations like the discrete cosine transform DCT and the discrete wavelet transform DWT, which enabled more sophisticated hiding methods while maintaining the visual and auditory quality of the media, which means you can do steganography in audio files. You can also do them in visual files as well. And I'll talk about that. And as digital media expanded to include audio and digital files, these STEG grew more diverse and used different techniques and use widespread spectrums to transform the domains. These advancements made detection increasingly difficult, prompting a continuous arms race between stenographers and cybersecurity professionals. In today's world, STEG has embraced cutting-edge technologies, including AI. Deep learning and neural networks have introduced capabilities enabling complex data embedding into multimedia formats. Innovations like homomorphic encryption allow computations on encrypted data without decryption, and covert channels in AI systems exploit machine learning models for data concealment. These methods ensure greater data security, but also challenge forensic investigators with detecting hidden communication. The scope of steganography has expanded clandestine communication to include applications like blockchain-based secure data exchange, digital rights management, and supply chain traceability. Businesses are exploring its potential to enhance privacy and ensure information sharing is a constantly evolving digital landscape. The historical progression and modern advancements in STEG highlight its adaptability and its enduring relevance. As it evolves, this field continues to play a crucial role in secure communication while posing significant challenges to cybersecurity, law enforcement, and forensic investigation efforts. This here is a basic table which just basically illustrates the flow of information in the steganographic process, where hidden messages, payloads, are embedded within the inconspicuous object, as you can, if you can view it, which is the cover object, to create a stego object, which is then shared and transmitted without arousing suspicion. Here's the breakdown. As depicted in the figure, this demonstrates the intricate process of embedding confidential information within a carrier file, effectively concealing it from unintended detection. The process serves multiple purposes, including secure communications, hidden data storage, and even creative applications. The outlined workflow highlights the steps involved in safeguarding sensitive information through steganography. Identify the sensitive information. The first step involves recognizing the data requiring protection. This can include, for criminals, like I said, it can include financial records, corporate records, personal details, or other critical information that's normally deemed confidential. Choose a carrier file. In this step, we're going to choose an appropriate carrier file to hold on to the concealed information. And I'm going to show you this later. This could be a JPEG image. This could be an audio file. Now we're going to do the encoding, which I'm going to show you as well. The final steps involves applying the stenographic techniques to encode the sensitive data into the carrier file. These methods ensure that the concealed data remains undetectable to unintended viewers while allowing the recipient to decode it securely. This process underscores the capability of stenography to enhance data security and facilitate covert communications, especially in settings where privacy is paramount. How are these criminals and these bad actors using these memes. Basically, they're using public platforms or dark web message boards for mass distribution. Criminals are leveraging this technique in a variety of ways to communicate. And one, embedding digital data into digital files. Criminals use digital files such as images, audio, video, and documents to hide this information by manipulating the least significant bits of the file. They embed hidden messages while maintaining the appearance of the regular file. For example, with images, embedded encrypted messages or instructions in the pixel data of the photos. Videos and audio, using frequency domain techniques to hide the information in the imperceptible spectrum of multimedia. Timing and communication. As explored in the study that I'm going to show, criminals use timing, stenography, and chat applications and network communications by manipulating the intervals between transmitted messages or packets. This allows them to encode hidden data based on time differences between sending and receiving text, use typing or reading behaviors to encode, transmit hidden messages with typical user activities. And then we're going to talk about the use of memes in social media. Again, this is very inconspicuous medium for sharing illicit or encrypted content. Cyber criminals embed code information into popular memes and distribute them on social media platforms. So just imagine, like during the elections, you could have easily had something with Kamala or Donald Trump, and you can just, and they had millions of images going around. So just a simple embed into one of those images and just post it on the message board anywhere, and your viewers or your recipient, they can be on the lookout for it, download it. They already have the password. They'll use decryption software, or they can go to a website and do it, and it'll give them all the information that they need. And then there's also, they use it through chat-based communication as well, through online chat applications, encode information in the timing in the messages or the response patterns. Also use prearranged codes or phrases to convey hidden meanings. And there's also the dark web, transmitting illegal files, contraband, pirated material disguised as regular content, encrypting and embedding illicit transactions or instructions within shared files to avoid detection by law. Again, I speak of the dark web, but you don't even have to go that far. This is something you can do on something simple like Instagram or Twitter. And then you have criminal communication by embedding hidden messages in inconspicuous files. Criminals bypass standard communication monitoring systems. This is especially useful in coordinating illegal activities, planning cyber attacks or terroristic attacks without raising suspicion. The misuse of this, criminals use publicly available software to hide and retrieve sensitive information. This includes tools like StegHide or OpenPuff, encoding confidential instructions or documents into multimedia files before uploading them to shared platforms. There's many challenges for detections. The sheer volume of files shared daily complicates detection efforts. Advanced stenographic methods, including machine learning-based embedding, are increasingly difficult for forensics to identify. So now you can put viruses inside of these. You can put AI code inside of different files, and when downloaded, it can wreak havoc to your system. Okay, this is the fun stuff, I guess. Okay, we have two images downloaded from X, Twitter, of Bernie Sanders. The image on the left is a regular, unaltered image with no hidden data. It represents a normal photo as it would be perceived by the human eye or standard viewers. This serves as the baseline image, with no embedded text, metadata, or other concealed information. The image on the right is modified. The image on the right, it appears identical to the original picture at first glance. However, it has been altered using stenography to embed hidden data, metadata, or other information. I have a little message inside that I'll show you later. These modifications are made in a way that is imperceptible to the human eye. such as adjusting the least significant bits of the pixel data. The minor changes do not affect the visible quality of the image, but enable the storage of hidden information. In this case, the modified image has been encoded with hidden data, allowing the concealed application to be transmitted or stored discreetly. Such techniques are used for secure, illicit communication to hide sensitive data, instructions, confidential material, or anything like that. Even malicious activities, like I say, such as concealing instructions for cybercrime. This brief example highlights how steganography leverages everyday media to hide data, which again makes it challenging for the general consumer and law enforcement's different officials and cybersecurity professionals. To explain this technology, this demonstration here highlights the use of a stenography to embed and extract messages and images. The tool encodes a message without altering the image's appearance, as you saw previously, and the decoding process reveals the concealed text. It showcases how images like memes can facilitate covert communications, emphasizing the need for cybersecurity to detect such methods. Okay, countermeasures. Steg analysis is the process of identifying and countering hidden communications. This has become essential in addressing the misuse of stenography for criminal activities. By uncovering concealed information or neutralizing objects containing it, Steg analysis seeks to mitigate the risk posed by secretive methods of data transmission. One area of focus is timing, where hidden messages are encoded within user behavior during activities such as chat communication. This methodology relies on analyzing patterns like the time taken to read, edit, or send text messages. While simulation-based tools have shown success in detecting these patterns, the approach faces limitations due to dependency on text-based applications and the variability in individual typing and reading behaviors. These factors often result in inaccuracies, false positives, highlighting the need for a more robust and adaptable detection method to combat this convert type of communication. With this, the first image is a photo of, again, Bernie Sanders, which was on a message board, simply downloaded off of the website X. It was likely used as a meme. The significance here is that the memes are commonly circulated images that can serve as carriers for hidden messages. The practice of hiding messages or data within images. Memes are ideal for this purpose because they are frequently shared and they're rarely scrutinized. The second image shows the output from an anti-steganography tool, ZSteg and StegHide. This is also a tool that's used to detect hidden messages within images. This is a detection versus having to upload the image, and this is a tool that can kind of find the information for you. The field of steganography detection, particularly in the context of memes, faces significant challenges and gaps in research. One of the primary issues is the lack of specialized tools designed specifically for identifying steganographic content within memes. Current technologies are often generalized and not equipped to handle the nuanced ways in which cybercriminals exploit popular digital media. Another critical challenge lies in the overwhelming volume of shared content across social media platforms. The vast quantity of daily uploads makes it nearly impossible for investigators to scrutinize every piece of content manually, thereby allowing concealed messages to evade detection. Additionally, there is an insufficient collaboration between public and private entities in addressing this issue. Effective steganography detection requires partnerships between law enforcement, cybersecurity firms, social media platforms, and academic researchers. The absence of coordinated efforts and intelligence sharing further hampers the development of a solution to combat the misuse of this communication. These gaps underscore the urgent need for advancements in detection tools and collaborative frameworks. Propose solutions. Develop advanced AI models to improve detection accuracy, integrate static analysis tools with social media monitoring systems, foster public-private partnerships to share threat intelligence. A proposed solution to address these challenges versus traditional methods which focus on statistical differences between steganographic and normal text have shown limitations in accurately detecting hidden messages in real-world scenarios. Large language models with human-like text processing capabilities often offer a paradigm shift by approaching linguistic staganalysis as a generative task rather than relying solely on classification techniques. I have a different type of technique where enforcement can use a tool called wget. It's free for Windows. This is a bulk downloader. This will save investigators times. You can download an entire website and it has all the images and all of that. This eliminates the need for manual navigation, enabling efficient retrieval for further analysis. This workflow saves substantial time by automating the tedious steps of image retrieval. So say if you want to go on the dark web, you can use a tool like this and just bulk download all of the uh, all of the images off the site, and then you can run them through like Stagnalysis software, and it will detect if any of the images or audio has hidden messages inside of. In conclusion, memes have emerged as a powerful yet covert medium exploited by criminals to hide illegal activity. This trend poses significant challenges to digital forensics due to the innovative and imperceptible methods employed by bad actors. To counter this, modern forensics tools must evolve, integrating advanced technologies like AI and large language models to detect and analyze hidden messages effectively. Furthermore, addressing these challenges require collaboration and innovation, as mentioned earlier. Partnerships between law enforcement agencies, technology companies, and cybersecurity experts are critical for sharing intelligence, ideas, and thoughts, developing new detection methodologies, and staying ahead of a rapidly advancing criminal criminal practice. By combining technological advances with corporate efforts, the risk posed by stenography can be mitigated, ensuring safer and more secure digital communication. Here is a list of my references, and I want to say thanks for watching, and I hope that you found this informative. Have a great day. Good night.